Let's delve into the Standard Model of particle physics. What is the Standard Model? The Standard Model is a comprehensive theory that describes the fundamental particles and forces in the universe, excluding gravity. It's a quantum field theory, meaning that it combines quantum mechanics with special relativity to describe particles as excitations of underlying fields. The Standard Model classifies fundamental particles into two main categories: fermions, which are matter particles, and bosons, which are force-carrying particles. Fermions have half-integer spin, for example, 1/2, and obey the Pauli exclusion principle. They are the building blocks of matter. Fermions are further divided into quarks and leptons. There are 6 types or flavors of quarks: up, down, charm, strange, top, and bottom. Quarks have a fractional electric charge and experience all 4 fundamental forces: strong, weak, electromagnetic, and gravitational. However, the Standard Model only describes the first 3, as it does not include gravity. Quarks combine to form composite particles called hadrons, for example, protons and neutrons. There are 6 types of leptons: the electron, muon, tau, electron neutrino, muon neutrino, and tau neutrino. Leptons have integer electric charge, or 0 for neutrinos. The charged leptons, electron, muon, and tau, experience the electromagnetic, weak, and gravitational forces. The neutrinos are electrically neutral and experience only the weak and gravitational forces. Quarks and leptons are organized into 3 generations or families. The first generation includes the up quark, down quark, electron, and electron neutrino. The second generation includes the charm quark, strange quark, muon, and muon neutrino. The third generation consists of the top quark, bottom quark, tau, and tau neutrino. Bosons are force-carrying particles. These particles have integer spin, for example, 0, 1, or 2, and do not obey the Pauli exclusion principle. The bosons in the Standard Model are the photon, gluon, W, and Z bosons, and the Higgs boson. The photon mediates the electromagnetic force. It is massless and has spin 1. The gluon mediates the strong force. There are 8 different gluons. They are massless and have spin 1, the W+, W-, and Z bosons mediate the weak force. They are massive and have spin 1. The Higgs boson is associated with the Higgs field, which is responsible for giving mass to the fundamental particles. It is massive and has spin 0. The Standard Model describes 3 of the 4 known fundamental forces. The electromagnetic force, mediated by photons, acts on electrically charged particles. The strong force, mediated by gluons, acts on quarks, binding them together to form hadrons, and also binds protons and neutrons together in the atomic nucleus. The weak force, mediated by W and Z bosons, is responsible for radioactive decay and certain types of particle interactions. The Standard Model does not include gravity. The Standard Model has several key features and concepts. It is a quantum field theory, which means that particles are described as excitations of underlying quantum fields. It is a gauge theory, which means that its Lagrangian is invariant under certain local symmetry transformations. This requires the existence of gauge bosons. The Standard Model incorporates the Higgs mechanism, which breaks the electroweak symmetry and gives mass to the W and Z bosons, as well as to the fermions. Finally, the Standard Model is a renormalizable theory, which means that its predictions can be calculated to arbitrarily high precision.